Well, ladies and gentlemen, I have something new that I'd like to share with you. It's called the Nvidia A100, our brand new data center GPU. The Nvidia A100 is based on an architecture we call Ampere, and there's several amazing breakthroughs that make this possible. The first is we're using TSMC's 7nm process that's been optimized for Nvidia, using a packaging technology called CoWoS, chip on wafer on substrate, 3D packaging technology, which puts the memory and the chip on the same substrate, which allows it to interoperate incredibly fast. And we're connected to HBM2 memory that now provides for 1.5 terabytes of frame buffer bandwidth. This is the first processor in history that comfortably delivers over a terabyte per second of bandwidth. The second breakthrough of the Ampere GPU is the new Tensor Core architecture, and it has a new numerical format, TensorFloat 32. It has the range of FP32, the precision of FP16. You input an FP32, it processes it with TensorFloat 32, and accumulates it in FP32. As a result, no code change is necessary when you train. Now, for some people who are ninjas, it is possible to optimize for FP16. But our experience is the vast majority of the world simply trains in FP32 today. And so with this new format, TF32, and no code change, all of a sudden, we can accelerate training tremendously. Let me show you here. On the left is V100 Volta's FP32 matrix operations. And on the right is A100 Tensor Core Accelerated TF32. The speed up is extraordinary. Ampere has a new Tensor Core acceleration for sparsity. It takes advantage of the fact that most neural networks are very heavily sparse. So it starts with a dense network, the original network, and it zeroes out the weights that are small or close to zero. And then it retrains that network. As a result, this network can be compressed 2 to 1. And using the same data structure, using the same pipeline, we can now effectively accelerate processing by a factor of 2. Let me show you the performance. Here, I'm going to show you the performance of Volta, which is today's state-of-the-art GPU. This is the highest performance GPU in the world today. This is the industry standard of deep learning. The black is Volta. The gray on top of the black is the peak, and the solid is measured. In the case of Volta, V100 FP64 is 8 teraflops. FP32 is 16 teraflops peak. FP16 125, and N8 is 60. In the gold will be the new A100 Ampere GPU. Look at that. A100 FP64 is 20 teraflops. A100 TF32 is 160 teraflops, 10 times. In the case of FP16, 310. In the case of N8, 625 peak. Now this is without sparsity. With sparsity, you get another boost. Look at the factor of 2. A100 sparse TF32 is now 310 peak. A100 sparse FP16, 625 peak. And for N8, the world's first processor to achieve over 1 petaops. This is now 1.25 pops, 1,250 tera operations per second. The inference performance of A100 is incredible. Now, when we compare it as an X factor to Volta, and remind you, this is the most advanced processor in the world today. The Volta numbers are all normalized to basically 1x. The training peak of A100 sparse TF32, nearly 20 times the performance of Volta. In the case of inference, 20 times the peak of Volta. This is the greatest generation leap we have ever experienced. Let me show it to you. Oh, boy. Oh. Ladies and gentlemen, the world's largest graphics card. This is the A100 processor board. It is 50 pounds, 8 GPUs connected by NVLink, 600 gigabytes per second, 6 NV switches, 1 million drill holes, 1 kilometer of traces connecting all of this, Over 30,000 components, 50 pounds. In DGX, it moves 700 cubic feet per minute. The most transistors on one computer the world has ever made. Ladies and gentlemen, the Nvidia A100 system board. It is just a technology marvel. But there's more. Ampere has a new architecture we call MIG. It stands for Multi-Instance GPU. It's the ability to turn one GPU into many. You could have one GPU, you could have up to 7 independent GPUs, or some combination in between. In the past, we would have a rocket ship with a very large payload. And while the payload is being filled up, the rocket ship is waiting. But as soon as the payload is filled up, the rocket ship flies to space like you couldn't believe. Well, with A100, you have the ability to run it as one gigantic rocket ship with a very large payload, or you could have 7 independent rockets, each with a smaller payload, but they could take off as soon as they're ready. And so for inference or public cloud, instead of having one person use a GPU, fractionalize it, create 7 different instances so that each one of the customers could rent a smaller computer. You now have the flexibility to do that. MIG is going to have a profound impact on how we architect data centers. When I talked earlier about how we would like to have a universal, a unified server architecture that allows us to scale up as well as scale out, and to be able to configure it as the workload needs, this is exactly what we mean. Ampere is not only incredibly fast for training, not only is it incredibly fast for inference, it also has the ability to fractionalize and partition itself up into a large GPU for scale-up applications or a whole bunch of small GPUs to maximize scale-out. Whether it's for inference or public clouds, you now have the ability to have one data center architecture for acceleration that is flexible, high throughput, and enables higher utilization. The performance is incredible right out of the box. This is BERT, one of the largest models and most important models today, BERT training and BERT inference. Compared to Volta, a platform that has been refined and optimized for 3 years now, right out of the box, A100 is 6 times the performance in training. 6 times. Transistor budget only increased about 70%. Now, Ampere is the largest, most complex processor the world has ever made. Thousands of engineers worked on it for several years, and it came together in this one incredible chip. 70% more transistors with great architecture delivered 6 times more performance out of the box. In the case of inference, it is 7 times the performance of Volta, and much more, over 12 times the performance of T4s. Now let me show you Ampere in a demo. This demo is a natural language understanding model that includes speech recognition. Not speech recognition of a human, speech recognition of a bird. The question that it has to answer is this: what is the native region of the bird that I'm hearing? First, it has to understand the question. It has to understand that the question has something to do with hearing the sound. Understand the sound, classify the sound, and then figure out from what region is that bird located, and respond as quickly as possible. In the case of V100, this is the result. First of all, it's a miracle in itself that we have an application that can do it at all. The breakthrough of artificial intelligence is pretty astounding. This next demo is A100 with 1 MIG. Just one of the 7 MIGs could achieve the same performance as an entire Volta, the world's state-of-the-art GPU. Now what happens if we put all the MIGs to work? All 7 MIGs. Wow. A100 with all 7 MIGs could do over 500 queries per second. With Volta, we could do about 80. So Ampere has 7 times the inference performance of Volta. This is pretty extraordinary. Ladies and gentlemen, NVIDIA's brand new data center GPU, the A100.